We're zipping straight down the coast to Lake Macquarie, and I'd like to welcome Claire Chaikin-Bryan to join us and tell us about the amazing work she's doing down in Lake Macquarie with her team.
Hi everyone. I'd like to kick off today by acknowledging the Awabakal people, the traditional owners of the land in which I'm broadcasting from, and pay my respects to elders past, present and future. They've been innovating for 40,000 years and more, and I think we should continue to be inspired by them and inspired by what they do. Just a little history. Lake Macquarie, we're about 90 minutes to 2 hours from the centre of Sydney. We're over 700 kilometres in area, and we have about 200,000 residents and a gross regional product of about 10 billion. We're part of the larger Hunter region, which is currently transitioning from coal. So like many today, we similarly have the Things network. We've deployed quite an extensive network around our community, in particular to not only support council operations, but to also support our local community in advancing their work in the Internet of Things space and getting experience in that. We recently, earlier in the year before COVID restrictions, ran a number of in-person workshops with our community where they got to see the end result from connecting a sensor to the network to seeing the data come through to a dashboard. There are lots of projects I could talk to you about related to the Internet of Things that we do as Lake Macquarie City Council, but I'm going to talk about smart beaches mainly today. So the Smart Beaches project was a project that was funded around under round 2 of the Smart Cities and Suburbs program with the federal government. It was all around making beaches smarter, safer and better using technology. We also were the recipients of the 2020 Australia New Zealand Smart Cities Award for Future of Place. We employed a lot of different technologies as part of the grant project, and we continue to actually expand and use these technologies. And I'm going to take you through a few of them today. But this diagram was a nice sort of infographic that we put together to help us communicate with our community about what we were putting out on the beach and the different things we were looking at. And we found it a really good communication tool because it was visual, but a little bit fun. And but also helps with these sorts of presentations to give you a little bit of a summary of the different types of technologies we experimented with as part of the project. Now, one of our key pieces of technology, hopefully, there we go, play, was using cameras to count people on the beach. The number of people on the beach is actually a critical data point for understanding what level of risk you have at your beach, and then leading into how many lifeguarding resources should you have at your beach at a certain time. So this is a bit of a time lapse showing a little count. You can see those pink boxes popping up on the screen where the camera, where the machine vision is picking up numbers of people. Now, when we started the process all those years ago of exploring this concept, we went through a number of different technologies to from could we count people using pinging their phones, Wi-Fi, to infrared break beams, things like that. We did conclude that cameras are the best solution. However, although everyone said, yeah, people counting, easy, cameras, we can do that. The problem was all the algorithms have been trained on urban environments. They weren't trained on a beach environment. You can see with the waves in the ocean and the sand, you get people lying down. It's a busy sort of environment for a machine to be looking at, particularly when it's been trained on, very plain concrete environments. You can also see the width of the screen that we're looking at. People can be quite far away, so they have less pixels, which makes it harder to count. So it actually has, it does take time to train these algorithms. But the result is this. you get a dashboard like this, where we can actually see counts. So we get hourly counts based on an average of an image taken every 15 minutes of the beach. And then that forms into also daily counts. Our counting can be done both live, so sending the image to the machine vision processor, which Unleash Live are running for us. And it can also be done at night as a batch report and given to you the next day. We also look collecting data on getting data on nearshore wave height, in other words, swell. We use Manly Hydraulics Lab, have developed a model which is based on offshore buoy data. So there's an offshore buoy always recording data. They both have a predictive model as well as a model for real time. They then use the data that's coming off that buoy to tell you what it is going to be at your beach. And you can see here in this graph, this just shows you what the predictions were that the buoy was predicting and what the actuals were based on the model. Now, this is all a model. There's nothing at the actual beach measuring this in reality. However, extensive testing was undertaken to get these results. And we actually have this data, they have this data in this model set up for the whole of the New South Wales coastline. However, I believe that it could be expanded to the rest of the country. We're also looking at continuing to do some testing in this space to revalidate after a number of years since that this model's been running to essentially revalidate that the data of that model that is based on that offshore buoy is coming in, is predicting correctly at these beaches. But we have a pretty good idea that it is doing a good job. So here's an example image at two of our beaches, Redhead and Blacksmiths. The offshore buoy is recording a 0.86. It's based on the model, it's saying 0.39 and 0.48 at Redhead and Blacksmiths. And you can see the water's pretty flat. So, plus you can see, actually, this is 1st of August. There are quite a lot of people on the beach there, you can see, and even people in the water. So even though it's winter, there are people there, but we have no lifeguards on duty. And this is one of those key drivers around this project of understanding, days when we have things like this, should we be actually having lifeguards there on duty? It's one of the key questions that we're looking to answer through all of our work in this space. And you see again, a big difference predicting big swell and Redhead, smaller and Blacksmith. And you can really see that validation through the imagery. One of our key IoT devices that we found real success in is these GPS trackers from Digital Matter. So this is actually tracking history over a couple of weeks in January of one of these lifeguard rescue boards. And it's really interesting data to explore and look at and to get a better understanding of how much activity is being undertaken and the equivalency of that with the number of rescues that are being undertaken. You can also see this is one of our jet skis. This is for the whole season last year. We don't stick to just our beaches. Our lifeguards are going down the coast to check on other unpatrolled beaches and, if they're getting alerted to calls. But you can see they can cover quite a large distance on the jet ski. So if this is really interesting, important data to use to understand that level of resourcing need that you might need to have. We also track things like signs and flags and when they're going to be up. And this table actually shows me over January in the season, we had one day where we had the shark sign up, and actually that coincides with when the beach was closed. We can see in a number of times where we've had stingers sign go up and that beach sign closed up. And this helps us, get that better understanding of really what is happening and when it is happening, and get data that hopefully one day will lead to our lifeguards not having to do a manual process of writing down when they're doing these activities. Communicating with public is also a really important aspect. You know, beach safety is not just having our lifeguards there, it's about communicating with the public about what's going on at the beach. We have 2 of these signs available that essentially, you know, we can roll out. They charge overnight. We can also put them into mains power if we need to. And they go through and they tell you, you know, there's a lifeguard on duty, what the local conditions are, who the lifeguards on duty are, weather information, water temperature, swell, tide. And we've also got an ability to add a little, for the lifeguards to add a message on this board as well. All the data that's feeding into the sign, we now have automated. So no one's having to touch, you know, put in the weather data, put in the water temperature, put in the swell, all of that data they don't have to put in. All the lifeguards do in the morning is come in, put who's on duty, and they can add their little message if they want to. We've also been working on an app to make a consistent process for lifeguard data entry across New South Wales. We have a group called the Coastal Safety Group. If you are interested, please let me know. We can hook you up to that group. We have a bit of community practice of going both nationally and internationally around smart beach technologies and improve using these technologies to help improve safety and communication. Although smart beaches is a big topic, I thought I'd also squeeze in another separate one about the humble light pole. So a lot of us know poles, they're great assets. We can put our sensors on them, solar, battery power, you can get them up there. You know, these are our, we'll call dumb smart poles. they're the platform for installing things. But they're a great resource and we've used them a lot. However, us, like many councils, have gone down the smart pole journey. We have, this is our first 9 smart poles in Charlestown. And we've done things with them like CCTV and Wi-Fi, putting some like air quality sensors and things like that. And really, you know, what makes these poles smart is about the ability to have electricity to different resources, as well as, you know, these ones have data. But the key thing I want to sort of take away is, you know, you don't have to have data. You don't have to have electricity to every hatch in your pole. You know, there's great value in having a smart enabled pole. You don't have to build everything first, just have it all enabled there for in the future when you want to use it. One of the sort of new things in the space that's going to make some of our, we'll call it dumb poles smarter, is things like having the Zaba receptacle on new street lights that are being installed. This doesn't require you to change the pole, but it does require, you know, when you replace your street light to LED, for example, you can have this Zaga port and you can have lots of different sensors and that can be powered through this. And you can also control the lighting with this. I believe ARC's group might be talking about this later today. We recently run a Zaga hackathon where because this is such a new thing, it's really an emerging space in Europe and places like that. We recently ran a hackathon with businesses that have a presence in New South Wales and a couple of local businesses included in that, to sort of explore what can you do with Zaga. And it's unbelievable in such a low power sort of environment. You know, they really want something about 2.5 watts to about 5 watts is your max. You can really do lots of different things. Things like machine vision counting, people, cars, bicycles, you name it, you can fit it in there. Environmental sensing, Wi-Fi counting, motion detection. You use your motion detection, you turn your lights on and off. You need noise detection. One of the most left of field and interesting projects that came out of this hackathon was Core Electronics created BirdFlow, which is a sensor that uses the songs of birds and some machine learning to detect what birds are in the area at what time. So there's some really cool stuff out there that you can do, and I really encourage you to explore this sort of space. And I really encourage you, you know, in all of these projects, experimenting is key. Don't give up, particularly if something isn't going right. do more of what's not working, do more of what's working, and do a bit less of what's not working, but keep persevering, because, you know, smart cities projects don't always go to plan, and we have definitely found that. But, you know, you keep at it, and you keep growing, and you keep changing, you keep learning, and, you know, just be brave, experiment, take the leap of faith. Thank you.